The objective of this lesson is to divide a 4-digit dividend using the open area model. With this model, students will subtract out partial quotients, which are multiples of the divisor. In previous lessons, students have divided 2- and 3-digit dividends using open area models up to the hundreds place. Today, we will extend those skills to divide a 4-digit dividend, or one that extends into the thousands place. To make room for the thousands place, the open area model or rectangle will be drawn even longer to include partial quotients to the thousands place value. Remember that open area models use the partial quotients method for division. We are subtracting out multiples of the divisor according to place value. Let's model division with the open area model for the following problem. The Just Dance Company sponsors 4 dance camps in different cities throughout the summer. They give out a free water bottle to every camp participant. They have 5,115 water bottles, and they need to determine if they need to order any more. How many water bottles do they have to give out at each of their 4 summer camps at this point? To set up the problem, let's draw an open area model with 4 on the left as the divisor, or the number of camps, and 5,115 as the dividend or the total number of water bottles on the right of the area model. Let's begin to determine whether groups of 1,000 can be dispersed into 4 groups. We know that 4 times 1,000 is 4,000, so we can subtract the product of 4,000 from the dividend 5,115. We will place the partial quotient of 1,000 at the top of the area model and show within the model the product of 4 times 1,000, which is 4,000. Next, we can subtract out the first product of 4,000 from the dividend. 5,115 subtract 4,000 leaves us with 1,115 water bottles left. We do not have any more thousands to share. So, draw a vertical line to show the completion of division by 1,000s on the area model and move on to the hundreds place. We have 1,115 left from the dividend. What do we know about multiples of 4? We know that 4 times 10 is 40, 4 times 100 is 400, and 4 times 1,000 is 4,000. It looks like we will need multiples of 100 because multiples of 1,000 is too much. 4 times 200 is 800 and 4 times 300 is 1,200. We only have 1,115 water bottles left, so we will use 4 times 200. Place 200 at the top of the area model as another partial quotient and write the product of 800 inside the rectangle. When we subtract 800 from 1,115, we have 315 water bottles left. Let's draw the vertical line to show that we can no longer share hundreds and look at the 315 water bottles we have left. We know that we cannot multiply 4 times 100 because it is too much. So we will look at multiples of 10. 4 times 20 is 80. 4 times 40 is 160. 4 times 80 is 320, and that is too much. Let's use 4 times 70, which equals 280. Let's write the 70 at the top as another partial quotient and the product in the rectangle, 280. As we subtract out the partial quotient of 280 from the 315 we had left, we are left with 35. We know that 4 times 9 is 36, and that is too much, so we will use the products of 4 times 8. Write the partial quotient of 8 on the top of the area model and 32 inside the rectangle for the product of 4 times 8. Subtract out the 32 from the 35, and we have 3 water bottles left over. When we add the partial quotients of 1,000 plus 200 plus 70 plus 8 plus the 3 remaining water bottles, it equals 1,278 participants that will each receive a water bottle, since 4 times 1,000 plus 4 times 200 plus 4 times 70 plus 4 times 8 plus the 3 left over equals 1,278. Please note that there are many different ways students can subtract the partial products from the dividend. Knowing multiples of single-digit factors from memory will be the best help for students as they use the inverse operation of division, which is multiplication, to solve their division problems. The objective of this lesson was to divide 4-digit dividends using the open area models. We met this objective by subtracting out multiples of the divisor to form equal groups and the open area model.